Good evening, everyone. I hope you can see my screen. My name is Ramanuj, and today I'm going to talk about Apollo GraphQL and how we basically use in Rabo Bank. I'm not going to talk about the whole Rabo Bank, but mainly about the insurance domain where I work. So, uh, so who am I? As I said, my name is Raman Prasad, and working in Rabo Bank as a front-end developer through Sojati. I have more than 9 years of development experience in front-end, and I'm basically from India and living in Netherlands since 2016. So that's about me. Uh, so the agenda is to first talk about how was the previous solution designed, and then I'll also go through uh, how did we implement it in a new architecture. So let's start with the previous solution. Uh, it was backend driven, so it means the customer journey was driven by completely backend. Which means all the data were coming from backend. For example, if you have to call on a link, the link was coming from backend. Also, most of the functional logics were basically written in a backend. So that was the one thing. Then it was tightly coupled. Our front-end application was tightly coupled with the backend. This means changing in one place, changing the code in one place or moving the code from one to other place would require a lot of testing efforts. So it was as I said, tightly coupled. Uh, Testing was much more complicated. Like if you change something, then it had to you had to do a lot of testing. Yeah, which was really not an easy task considering more than 17 insurance applications. So it's not one; it's like more than 17 insurance applications. So you have to do a lot of testing. So it's not really easy testing things. Then it was slowness. I said since it was backend driven, there are a lot of calls were made. Basically, a lot of HTTP calls were made to the backend. So this was especially requires lots of. The application was quite slow because of that. And then old tech stack. The front-end application was mainly built on AngularJS, and it was kind of micro front-end projects. So every application had their own repository and their separate Jenkins pipeline. So maintaining these were quite difficult. So how we implement it. So this is how our new solutions look like now. Our backend team basically were creating microservices for every insurance actions. That is something like flow-wise. Uh, Earlier we had insurance specific endpoints. So backend team thought, let's create the feature specific endpoint, and we also had since we had a single source of truth in our backend, we also wanted to only get the data which we need from the backend, not everything. So we created middleware with GraphQL. And another thing was that the bank-wide strategy was to also bring everything on Angular 7 at that time with a new architecture. So we decided to also recreate the front end. So the middleware part and the front end parts, almost everything recreated. So now we have one single endpoint that we say Google GraphQL endpoint, which we call from our front end, and then middleware has to decide how many calls to. It has to decide which service to call, how many services to call based on the schema or the query which we pass. Uh, in new architecture, we also use Azure pipelines features. Azure features basically not a repository pipelines. It's releases, compliances, artifacts. So a lot of things from Azure, and basically Azure pipeline generates all those artifacts, and at the end that gets deployed to the PCF. So that's how it is in a new architecture. We chose Apollo GraphQL. Yeah, so why? Based on the research at that time, we figured out that Apollo GraphQL when Apollo server and Apollo client are the best tool in the market. And the main benefit was that we had to deal with one single language throughout, that is TypeScript. So that's the only reason. Of course, there could be some more reason, but that was the main reason for us to go with Apollo GraphQL. Okay, so before we proceed further, first let's try to understand, because we are talking about the GraphQL. Let's try to understand GraphQL in nutshell. So as we know, GraphQL is a query language for the API, so that allow you to ask different types of data basically in one go. That is very briefly what it is for and why it is awesome. I have taken an example here from from GraphQL website. So as you see, it tried to query title and opening crawl, and also trying to query rating field, but the rating field doesn't exist on type field, so it throws an error while typing itself. So that's quite sometimes handy when somehow if you are mistyped or asking for data which is not a part of your schema. But the title field and the opening crawl field was available. So the request is all the way sent to the backend, and then backend knows what data it is querying for, and backend will respond you with the title and opening crawl value. And it does not respond with any other data. So you ask for two data and you only get the response for those two fields. So and you also see like it generates a nice document. So if you want to check the types of a field, you can just click through, and then it's quite handy. In a classical way, when you ask for data from a server, you get all the data which server has, even though you do not need for your front-end applications. So that is what about the GraphQL on nutshell. Let's move ahead about the GraphQL middleware. So what we did, we created a middleware, and what middleware is? Middleware is basically a server, and that runs on the node and our backend application, that is microservices. So it lies between the front end and the backend, the middleware part. We call a single endpoint every time from our front end and query the data what we need. We do not need to basically think where the data is coming from, the front end. So whether it is coming from this service or it is coming from another service, we just ask or send the query to the middleware, the data which we need, and then we get the answers. And basically, middleware has to aggregate the data from different microservices that are available. So that's about this. And then what we use in the middleware is GraphQL module. Basically, GraphQL module, why we use, because it helps to create easily maintainable, reusable, and then testable, extendable modules. So the basic concept being the GraphQL module is to separate your GraphQL server into smaller and independent feature-wise modules. That's how you can see also in the diagram. And so this GraphQL module library helps to organize your schema types and their associated resolvers into the multiple modules or files or anything related to a specific part of your app under a module. So that's about the GraphQL module, and that's how since we also deal with large applications, we decided to use this cool feature in our middleware. This is how the GraphQL. So inside the GraphQL, we also have. We use services. We write services. We write schema. We write services, resolvers, and then specs. I'll also go through one by one during this presentation. Due to the compliancy issue, I cannot show you the actual code, but these are basically some examples code to explain you better how we create those specific things. So this is one. This is how we create the GraphQL modules. And this is about the types, the schema part. So this is how we create the schema. As you see, I created the schema product types using the post GraphQL module. And then in this schema, we pass is a product, we pass the ID, and then you have the output. I mean, you are expecting title, thumbnail, category, rating. So you need to define your types and the schema. If you notice here, we have used the exclamation mark. Uh, that is uh, that is just to make sure it is a kind of guaranteed that it is always there. Otherwise, it can be nullable. So, for example, if any GraphQL, I mean, if you query a field and data is not available, in that case, you might get null. So, when you make this symbol, exclamation mark, then it is a kind of guarantee that you're going to get this data. So that's about this. And then we use these are just normal service where we basically configure our microservices endpoint. Then we have resolvers. So let's first try to understand what this resolver is. So basically, a resolver is a function that resolves a value for a type or a field inside a schema. In this example, I want, for example, I want to query number 6 because I always need a fixed digit number 6. We can write this kind of logic in inside resolver. But just to explain this resolver part, but also while returning the data from the microservice, if you want to do some kind of manipulation in between, so between the microservice and front end, if you want to do some kind of manipulations, that logic you can write inside a resolver. We also write specs. So in our middleware, we have created the specs, something like this. Not yeah. So what it does, we basically we do a snapshot testing. So when we run this query and mutations against our stub service, and then it creates a snapshot from the backend. And we have also created integration test case using that. So when the build runs, integration test case also runs, and it verifies that the query results are basically matching with your generated snapshot. So it's another layer kind of testings in our for middleware queries. So that's about the GraphQL middleware part. So I just showed you the middleware part, middleware side, and this is the front end side. In the front end, we have Apollo CodeGen along with the TypeScript Apollo Angular. We use Apollo client caching, and we use Apollo client state management. And I'm going to explain you a little bit to understand how we use that. So let's start with Apollo CodeGen. So what Apollo CodeGen does, it generates TypeScript types for any query and mutations written in your Apollo client project. Of course, you have to make sure that you have given a valid GraphQL schema. If you see in this example, I have on the left side, I have get product. So this is how we write the GraphQL file names. And when you query these products, like so we have a query in the left side. When you query this, so this is the query, and when you run the code gen, then these are the tags it generates for your. So that is what the code gen does. Apart, so that is, and then we along with the code gen, we also use TypeScript Apollo Angular plugin. So in the configuration file, we have also configured this TypeScript Apollo Angular plugin, and this plugin basically generates Angular services with the TypeScript typing, and it basically generates a strongly typed Angular service for every defined query or mutations or subscriptions. And yeah, so we use this Apollo Angular plugin because our front end is using Angular, so and we need those types. So yeah, so what we do, we make our middleware service running so that it takes the query from our front end and run against the middleware to generate these types and also those services. So you have here the types, which is basically tied to your middleware. So that's why we turn the middleware with that. And this gives you basically an extra layer of kind of security, you say, or you say trust, that because your types are tied with your front end and back end. So it gives you an extra layer of kind of trust that is going to work. If you see these Angular services, these are very small, very simple Angular services. It does not do a whole lot. It has basically, it extends the Apollo query, and yeah, and it has some. It has the document, but these documents are basically same as the query. But the main thing is that it creates injectable. You see, it makes injectable, which means that you can use this service like a normal service, normal Angular service in your component. So, so how we use them? So the left side you see this is how we maintain our folder structure. We keep our GraphQL file along with the components. So if you see this product.component, GraphQL is along with the components, just for easy maintenance and understanding. As I mentioned before also, due to the compliancy issue, I cannot show you the actual code. These are just example codes to make you understand these things. On the right side, what you see is we import the generated service from the this code, so code output files. So this get product query or get product GQL, these two we import from the generated files, and and we are using in our constructor, as you see, as a kind of a normal service. We injected here, and then yeah. So if you see, I also use the fetch method here. This is just one way to basically get the data from your middleware. A nice thing is that it always returns an observable. So so you can pipe and do what we want to do with the data within the sprint. So since it returns observable, you can do all those RxJS magics. And as you see, this response type is also using one of the type generated by the Fortune file. So you're making type set. And that's how we use this Apollo code along with the Angular Apollo. Then we have a caching. We use Apollo client caching. What actually Apollo client caching does is it stores the result of your GraphQL queries in your local normalized in-memory cache. This means that everything you are going to query with a GraphQL and coming from the middleware will be added to your cache. And I have just an example to show you how basically the cache looks like. I've used here a plugin that is it's Apollo client dev tool extension in the Chrome you can use just to show you how the cache looks like. And what it does, like basically Apollo, so it stores the data with a reference. So it stores the data with a reference or to the ID automatically. And the main thing is that this is done by Apollo. This is completely managed by Apollo. So you don't have to basically worry about whole lot. And this is just a clear benefits with using the Apollo cache. And whenever we run a query for an endpoint, it first checks whether it exists in the cache. And if it is found, then it will result the data from the cache. But if it is not found, then it will try to query the data from the remote through the middleware. And then responsibly first add to the cache and then come to the browser. And this is also we call as cache first fetch policy, which is basically default fetch policy in Apollo. There are of course some cases where you do not want to use your cache. You want to use a different, or you want to use the cache but different way. So there, that's why there are different kinds of fetch policies to handle that. And these fetch policies are basically you can configure based on your need. We just saw before in the slide we saw a fetch function to get the data from using the GraphQL service. This is just an option you can give to the fetch function. So yeah, so that's about this caching. I mean, as I said, we don't write any separate services to manage the cache. It's completely handled through that. Then we also do state management. Another cool thing is that we do the state management, and the reason we do state management in the GraphQL is we want one way to get the data, no matters where the data is located. And we have why? Because we have many multi-step form in our project, and every step does not have a service call to the backend. But we do need to store the data when the customer navigates from back to forth, and it does, and it doesn't need to basically query to the backend. So it's just the local state, but we use the GraphQL for this as well, and that allow us to have it accessible exactly the same way as other data. So there is a single way to access the data, and that is why we use this state management thing in a GraphQL. As I said, we can combine the local field only local field along with a remote query. So if you see this example below, we have combined, if you see this example, name and price are something going to come from remote, and each card is a local only fields. It's not going to, so this add get client is just to tell that it should never go to the middleware for this specific field. In this way, it is a little bit the same way as kind of cache only policy in the of a fetch policy, but the main difference is that it is a part of your query, so you define directly at the query level. So this is how we write each step to the state, and yeah, we have very simple way to manage the local state, and same way to also manage the remote data. So we have single query. With the query, you also manage the state, local state, and also the remote state. Any question?
What the timing! great timing. Nice. Well, in that case, well done. I think we are very happy with your presentation as well. Just like with Roy, I think it's very nice if we applaud him with the emoticons. That would be really nice for him as well, since we cannot do this live. Well done. Yes, there are a few questions, Ramanu, but first I want to say it's very cool to have an insight into the architecture of Rabobank and a small overview as well, to see it like this. Not a real code, but that's no problem. I get the point, so that's good. The first question, here it comes, is from Tom Cool. Nice name, by the way, Tom Cool. If your team goes for a GraphQL strategy, what would be the approach to build your API endpoints? And in what way does it differ from REST?
Yeah, so if you have seen the example, so let me first answer the second part first. So it differs from REST because when you, for example, when you ask for or when you query or when you send or you ask for data, you get everything what a server. For example of an employee service. And employee service has employee name, employee ID, employee address, and all the things. And in your application form, you only want to show employee name. You don't want to show anything related to his address or ID, anything. You just need name. But when you call the REST, the service will respond you all the data. It's not going to filter. It's giving you every data, and in the front end you have to basically do all the logic to only show the names. But you always get all the data. But with the GraphQL, this is something what you ask, you only get that. So if you ask for name, now middleware has to decide and has to it has to query what data you have asked from the front end, and you get that. So that's clear benefit. You basically deal with a less amount of data, so your performance will be better. First part was about. Can you repeat the first part?
Sure, I can repeat the first part. That's no problem. I'll scroll back to the question. There are a few more questions for you as well, so that's no problem. Let's see. If your team goes for a GraphQL strategy, what would be the approach to build your API endpoints?
Yeah, so as I said in the beginning, like when our team started building these microservices, we also had, so before that, like all our endpoints were like insurance specific. So, like example, for auto insurance, there was a separate endpoint. For like home insurance, there are separate endpoints. So they thought, why can't we make it feature specific? Like for example, because For example, inventory. So in case of inventory and home, they are always going to call address service, for example. So why can't I make one address service which can be used by both the insurance? So it's better to organize your backend based on the flow wise when you are going to build GraphQL or basically set the microservices.